Hey there, today we're working on system notes number 11, solving systems by substitution, and this is multi-step. So number 10, the notes number 10, we already had our x equals. Today we don't have our x equals, so we're going to have to figure that out. Okay, so just like when we graphed lines, we had things that said infinitely many solutions. When you had infinitely many solutions, when you graphed one of your lines, you would graph and it would look like that. And then you'd go and graph your other line and it would land exactly on the same line. Or you could also have, when you get your x's and y's and they both kind of cancel each other out and you get like 6 equals 6, that would be when we said infinitely many solutions. And that happens when both variables cancel and what's left is equal. Okay, we also had, when you graphed a line, it would look like this, and then you'd graph your other line, and it would look like this. And you'd have parallel lines. Okay, parallel lines are when we said no solution, and it would be something like 0 equals 8. Well, we know 0 does not equal 8, so that doesn't work out. So when both variables cancel, and what's left is not equal. Okay, and that's when you're going to have parallel lines. So you could have infinitely many solutions, meaning what's left is equal, or you can have no solution, what's left is not equal. Okay, the first thing we're going to do, so when we're going to set up by solving by substitution, we're going to solve for a variable. Okay, what that means is we want just our x or just our y all by itself on the left-hand side of the equal sign. Okay, once we have that all by itself, we're going to substitute its equal expression into the other one. So this is just like what we did yesterday, or on the last lesson, depending on when it was that you did it. So we're going to substitute that back in. So really the only new step today that we're going to do is number 1, solve for the variable. And then once you do that, you're going to solve for the remaining variable, and then you're going to substitute that value in. So really, essentially, you want an x and a y. Okay, so let's look at number 1. Let's do this so it makes a little bit more sense. So notice that neither one of our expressions or our equations say x equals or y equals. But the easiest one that we could get into x equals or y equals is this bottom one. And the reason I can do that is I have x plus 2y equals 15. Notice that your x is all by itself. It doesn't have any like number in front of it. So if it had a number in front of it, you would have to divide by something, and we don't really want to do that. So we're going to look for the equation that has just an x or just a y that does not have a number attached to it. Okay, and to get it all by itself, I'm just going to say x equals, or sorry, not equal, sorry. We're going to just rewrite it, x plus 2y equals 15. Okay, I'm going to do my left side, right side in blue for right now. Okay, if I want to get x all by itself, I'm going to get rid of that 2y. So I'm going to say minus 2y on my left side and minus 2y on my right side. Okay, which leaves me with just x on my left side equals, if I have a 15 and a negative 2y, that negative 2, we can't combine those because one of them is a y and one of them is not. So negative 2y is going to come first, and then plus 15. Okay, so now you notice you have x equals. So now we can take everything that x equals, and we can go to the other equation, so the one on top, and I'm going to stick that right where my x is because it's what my x equals. So now I'm going to rewrite my top equation. So I'm going to start with my 2, and instead of writing x, I'm going to say negative 2y plus 15 minus 3y equals 2. So I'm just following it all the way through. And now we're going to solve just like we did on the last assignment. Okay, so I have a 2 outside of my parentheses, so I have to distribute. 2 times negative 2 is going to give me a negative 4y. I'm going to take 2 times 15, and that's going to give me a positive 30. Okay, we're not going to distribute that 2 to that negative 3y because it's outside the parentheses. So I'm just going to write minus 3y. And then equals 2. Okay, when I look, I have a negative 4y and a negative 3y both on the same side of the equal sign, so I can combine those terms. So negative 4 and negative 3 is going to give me a negative 7y. I still have plus 30 equals 2. Okay, if I want to get my negative 7y by itself, I'm going to subtract 30 and subtract 30. So my negative 7y is going to be equal to, if I take 2 minus 30, I get negative 28. Then I want to divide by that negative 7, divide by negative 7, and I get y equals 4. Okay, so now that I have my y, I need to find my x. So I'm going to put my solution up here, my ordered pair up here. Okay, my y is a 4, so I'm going to put a 4 where the y is. So now I need to find my x. The easiest way to do that is this one right here that you created. If you got x all by itself, then all we're going to do is stick this y that we just found in this y spot right there. So let's rewrite this. X, oops, I do that all the time. X equals negative 2 parenthesis 4 plus 15. So I'm going to keep my x on my left side. I'm going to say x equals negative 2, and it's outside the parentheses, so I'm going to distribute that. That's going to give me a negative 8 plus 15, and then I get x equals 7. So I'm going to take that 7 and put it right where that x is up at the top. Okay, let's look at number 2. Okay, again, we're looking, so we have our x or a y that's all by itself, that's not attached to another, to a number. So at the top equation, I have 7y, and it has a 7 with it, so I don't want to use that one. And my x has an 11x, so I don't want to use that one. So let's look at that bottom equation. I have x minus 3y equals 0. So because that x doesn't have a number attached to it, let's use that one. So I'm going to change that, and I'm going to just rewrite x minus 3y equals 0. And this time I want to get x all by itself. So to get x all by itself, we got to move over that 3y. So I'm going to say plus 3y plus 3y. Now I have x by itself equals in the middle. Remember, you can't combine the 3y and the 0. And in fact, this one we can just say 3y. And do we have to write 0? Because is 0 really going to change your problem at all? No, it won't. So we're just going to leave that x equals 3y. So now I'm going to take this 3y and I'm going to go into the other equation, so the top one, and where my x is, that's where I'm going to substitute that 3y in. So let's go ahead and rewrite that one. So I'm going to say 7y equals 26 plus 11. Now I need a parenthesis, and I'm going to put my 3y in there, okay? Looking through that, I only have y's throughout my whole equation, so I know I'm on the right track. Okay, so now I'm just going to go ahead and solve. My 7y is still going to stay as 7y equals, my 26 is going to stay at 26, but now I need to distribute that 11 to that 3y, and that's going to give me 33y. So plus 33y. Okay, so when I'm looking, I have a y on my left side and a y on my right side, but also on my right side, I have that 26. So if we want to isolate those y's or get them all by themselves, we want to move everything that has a y over to the left side where only the y's are. So I'm going to subtract this 33y on my right side and subtract 33y on my left side. So if I take 7 and I subtract 33, that's going to give me a negative 26y. And then equals, those y's are gone and I'm left with 26 right here. Okay, and then I'm going to divide by that whatever is by the y, which is a negative 26, and I get y equals negative 1. Okay, so if I were to put that in an ordered pair, my y is a negative 1. So I'm looking for my x, and the easiest one is the one that we created where x is all by itself. So now I'm going to take this y, and I'm going to stick it where that y is right there. So I'm going to say x equals 3 parenthesis negative 1. My x is going to stay in x. I'm going to distribute 3 to that negative 1. That's going to give me a negative 3. So x equals negative 3 That negative 3 is going to go right there. Okay, so let's look at number 3. Oops, we're going to flip the page over. You got to flip over to there. So here's number 3 right here. Okay, so looking at this one, I have y minus 3x equals negative 4, and I have y equals 4 plus x. Well, this is a great one because when it says y equals, I can take all of this. This one doesn't require me to do that step, that first step. I'm going to take all of that and put it where that y is. So instead of writing y, I'm going to write 4 plus x. So 4 plus x minus 3x equals negative 4. Okay, 4 plus x minus, oh, that should be an x. I made that look like a y, but this is an x, minus 4. So looking through, all of those should be the same variable, and I have x's throughout the whole equation, so I'm good there. Okay, I have an x and a negative 3x. Remember, if there's no number in front of that x, it's really a 1. So my 4 is going to stay a 4, so I'm going to keep that. But my 1 minus 3x is going to give me a negative 2x. If I take 1 and I subtract 3, that's going to give me a negative 2. And I'm going to use that negative like a subtraction symbol. Equals negative 4. Okay, now I want to get rid of that 4, so I'm going to subtract 4 from both sides. I get negative 2x equals negative 8. And now I'm going to divide by negative 2, divide by negative 2, and I get x equals 4. Okay, so we have our x. I'm going to put that up here. And my x is a, oops, I put that in the wrong spot. My x is a 4. So now I'm looking for my y. Okay, the easiest one to do would be this one right here because it already says y equals. And we're going to stick this 4 where that x is. So now I'm just going to rewrite, and I'm going to say y equals, it starts with a 4, plus I'm going to put my x in, which is a 4. My y is still going to stay a y. These two 4s are the same thing, so I can combine those. So I'm going to say y equals 8. So I have 4, 8. That would be my ordered pair. Okay, let's go on to number 4. Looking at number 4, I have negative 4x plus y equals 6. And I have 4x equals 7 plus y. Well, both of those, my y is all by itself. So it doesn't really matter which one you choose to move over. I'm going to go ahead and choose that top one. Let's get that y by itself on the top. So I have negative 4x plus y equals 6. Okay, if I want to get that y by itself, I'm going to move that 4x over. Right now it's a negative 4x, so I'm going to add 4x and add 4x. Okay, so those 4x's are gone. I get y equals, I can't add my 4x and my 6 together because they're different things. So I'm going to say 4x. So I'm going to do plus 6. Okay, when I look, my y is all by itself, so now I can use that 4x plus 6. I'm going to take 4x plus 6, that right there, and I'm going to go in my next equation, not the one that I just changed, but my other equation, and I'm going to put it in for that y right there. So I'm going to start with 4x equals 7, and then we have plus. Usually we would use parentheses here, but because y is all by itself without a number right in front of the y, they're not attached, they're not being multiplied, I can just go ahead and write 4x plus 6. So I'm going to say 4x plus 6. Okay, looking at these, my 4x is going to stay a 4x. My equals is going to stay in equals. I have 7 plus 4x plus 6. When I look, I have a 7 and a 6. Those are the same term, that 7 and that 6. So those ones are going to equal together 13. So I'm going to put them together. So I'm going to say 13. Change that color. 13, and I still have plus 4x. So I have 4x equals 13 plus 4x. Well, remember, you want your x's on the same side. And because my 4x at the very beginning on my left side, because that one's all by itself right now, let's move the 4x on the right over there. So I'm going to say minus 4x and minus 4x. Okay, if I have 4x and I take 4x away, that gives me 0. Okay, those x's aren't there. We can't just put an x there because remember, if you have an x, that really equals 1, right? 1x. So I'm going to say 0 and then equals, my 4x's are gone, so I have a 13 right here. Okay, does 0 equal 13? No, those don't equal 13. 0 does not equal 13. So when we see that, we say no solution. Or you could say NS. Okay, so if they don't match, then, and all your x's and all your y's are gone, then it's going to be a no solution. All right, let's go on to number 5. Okay, again, we want to get either our x or our y by itself. When I look at both my x's, I have a -4 in front of one of them and a -5 in front of the other one. So we don't want to use our x's to get rid of, or to get them by themselves. And then let's look at our y's. Both of my y's are isolated, right? They look like they're by themselves. But because my top one is a plus y and my bottom one is a negative y, we don't want to do that negative y because that's really a -1. And remember, you can't have a negative y without dividing by a -1. So let's do that top one because of that negative on the bottom y. So I want to get this -4x plus y equals 6. Okay, so again, if we want to get that y by itself, we're going to add 4x on both sides. Okay, so my 4x's are gone. I got y equals, I'm not going to put my 4x and my 6 together. I'm just going to say 4x plus 6. Okay, so now that my y is all by itself, I can take this, and I'm going to go in my other equation, that one right there, so I can just, so I only have x's within my problem. So I'm going to rewrite all of that. When I get to my y, I'm going to stick in that 4x minus 6. But please notice that you have this negative in front of your y. So we have to keep that negative there, and then my 4x minus 6, or sorry, 4x plus 6 is going to go in parentheses. So I'm going to start with -5x minus, now I'm going to use parentheses, 4x plus 6 equals 21. Okay, so now let's look. That -5x is still going to stay a -5x. Because I have a negative in front of my parentheses, that's like a -1. So I have to distribute that -1 to each of those pieces. So if I take -1 times 4, that's going to give me a -4x. And now I have to distribute that -1 to that 6, which is going to give me a -6. Oops. And then I still have equals 21. Okay, these are the same thing. They're both x's and they're on the equal, are on the same side of the equal sign. So I can combine those. So -5x minus 4x is going to give me a -9x. I still have minus 6 equals 21. To get rid of that 6, I'm going to say plus 6 plus 6. I get -9x equals 27. Divide by -9, divide by -9. And I get x equals a -3. Okay, so I have, let's put that right here. So my x, which comes first, is a -3. So I need my y. The easiest one to do would be the one that says, that is y equals. So that one says y equals right there. So I'm going to take this -3 and I'm going to put it right where that x is right there. I'm going to say y. Dang, I do that every time. Y equals 4, parentheses -3, plus 6. Okay, my y is going to stay a y. I'm going to distribute that 4 to that -3. That's going to give me a -12 plus 6. Because I have these two are on the same side of the equal sign, I can combine them. So -12 plus 6, that's going to give me y equals -6. Put that -6 right there. Okay, so there's my final answer for that one. Okay, last one, number 6. This is a good one because I have x plus y equals 5, but I have an x equals. I like when it says equals right away because then I don't have to do that part where you have to solve and get it by itself. Okay, so that negative y plus 5, instead of writing it that x, I'm going to write negative y plus 5. So I'm going to start with negative y plus 5. So instead of writing x, I'm putting that, plus y equals 5. Okay, when I look at those, I have a negative y and a positive y. That's really like having a negative 1 and a positive 1. So those would turn into 0. So those two kind of cancel each other out. So what I'm left with is a 5 on my left side equals and a 5 on my right side. When 5 equals 5, then we say infinitely many solutions, or IMS. If those numbers match, if all your x's and y's cancel out and those numbers match, that means that you have two lines that land on top of each other, and that's infinitely many solutions. That means that no matter what, it will be a solution. All right, you are ready to do homework for number 11.